All right, welcome to the deep dive. We are diving straight into a topic that feels, well, almost like science fiction, but it's becoming very real very fast.
hmm
The global race for practical nuclear fusion energy.
Ah,
And this isn't just, a science project.
no, not at all.
It's a really high-stakes competition happening right now. Huge implications.
Absolutely huge.
You sent us this stack of sources, articles, reports, lots of analysis laying out the current state of play.
Hmm.
So our mission here in this deep dive is to, well, cut through the complexity a bit.
Right.
We want to unpack this whole landscape, understand the strategies, the progress of the key players.
Who's doing what, basically?
Exactly. And figure out what's really at stake if someone actually cracks fusion power first.
Mm-hmm.
Because this goes way beyond physics labs, right?
Completely. It's energy security, economics, global influence. It's all tied up in there.
Okay, let's unpack this. This is quite a story hiding in these sources you sent.
It really is.
Yeah.
And what's striking about the material you provided is how it frames fusion, not just as this grand scientific challenge,
Right.
but as this explicit geopolitical and economic contest. It really shows a dynamic race.
With very different approaches.
Yeah, clear contenders taking distinctly different paths. It's fascinating.
Totally. So before we get into the who and the how, maybe let's just spend a minute on the why.
Good idea. The motivation.
Why are countries, and private companies too, sinking billions into something this incredibly difficult?
Yeah, it's not trivial.
And like you said, these sources make it clear it's not just the coolness factor of building a mini sun on Earth.
Although that is pretty cool.
Yeah, it definitely is. But they point to, what, 4 huge areas of impact for whoever leads the way.
That's right. 4 key things jump out from the sources.
Okay, so first, energy sovereignty and security.
Mm-hmm.
Imagine, like, a virtually limitless clean energy source doesn't rely on fossil fuels.
Which means no more volatile global markets, no dependence on iffy supply lines.
Exactly.
Mm-hmm.
The sources really stress this potential for, like, genuine energy independence.
A complete game changer for national security.
And second, the economic advantages.
Oh, yes, the money.
The material estimates this future market trillions of dollars.
Trillions, yeah. The potential for growth, new industries, high-tech jobs. It's staggering.
A chance to really leapfrog forward, technologically speaking.
Definitely.
Third is geopolitical influence.
Right. Power dynamics.
The sources argue that, the country mastering fusion first could gain serious leverage.
Setting global energy standards, maybe? Having a huge voice in climate talks.
That seems to be the idea. Big influence on the world stage.
Makes sense.
And finally, number 4, technological leadership.
This one's interesting, too.
Yeah, because pushing the boundaries for fusion doesn't just help fusion itself.
No, it spills over.
Drives innovation in all sorts of related fields. The sources mention superconductivity, advanced materials.
Plasma physics, controlling these extreme states of matter.
Right. Stuff with applications way beyond just energy.
So, connecting this back to the bigger picture then. Achieving practical fusion isn't just adding another clean energy source.
Oh, it's more fundamental.
It could totally rewrite the global energy map, fundamentally alter the balance of power.
A paradigm shift, really.
Exactly. So, given these enormous stakes, the natural question arises, and the sources address this.
Who's actually leading?
Yeah, who seems best positioned right now in this race?
Okay, let's dive into that. The primary contenders highlighted in the sources. First up, China.
A major player.
Presented as a major frontrunner, and their approach is described as, well, heavily state-driven.
Top-down national priority kind of thing.
Yeah, and the scale of their strategic investment is, it's pretty eye-opening.
And the numbers are big.
These sources report China's central government is investing around, $1.5 billion a year?
Annually, yes. And for perspective, the sources note that's nearly double the current U.S. government funding we'll get to.
Wow. Okay. And it's not just the central government, right?
No, that's key. You see big support locally, too.
Like Shanghai. The sources mentioned a huge fund there.
That's right, a 10 billion yuan fund, which is, about $1.4 billion U.S.?
Just for state-backed fusion projects.
Yeah, specifically for fusion. Shows real local buy-in.
And all this funding, it's translating into actual technical progress.
You can see the results.
Their experimental reactor, East Tokamak, the artificial sun nickname,
Mm-hmm.
it hit that world record back in January 2025, holding plasma at 100 million degrees Celsius.
For 1,066 seconds. Over 17 minutes.
Incredible. Just to clarify for everyone, a tokamak is that donut-shaped machine using magnets.
Right, powerful magnetic fields to contain the super-hot plasma needed for fusion.
And keeping it stable at those temperatures for that long is a huge challenge.
A critical step towards making it work continuously. China's showing real prowess there.
The sources also mention other innovations, like their H870 reactor design.
Yes, using high-temperature superconductors for the magnets.
Why is that important? The superconductor type.
Well, these newer high-temp ones allow for stronger magnetic fields in a smaller space, potentially leading to more compact.
So smaller, maybe cheaper reactors down the line.
That's the hope. More efficient designs.
Okay. So big state funding, clear technical progress.
And what really jumped out at me from the material on China was the integrated nature of it all. Like the sources describe, they're not just throwing money at R&D randomly. They're building the whole ecosystem.
Infrastructure people.
Exactly. Focusing on infrastructure, yes, but also critically human capital. Developing the talent.
They mentioned the PhD pipeline.
Yeah, a really robust pipeline, graduating way more PhDs in relevant fields than many other places, and building these huge integrated facilities.
Like that campus in Hefei.
A Hefei campus, yeah. Nearly 100 acres, the sources say, specifically designed to industrialize fusion tech, not just research it.
Taking it from lab to factory, basically.
Precisely. And this whole approach seems, deeply aligned with their bigger national goals.
Energy security, like we talked about.
Energy security, and President Xi Jinping's whole Great Rejuvenation agenda. Fusion fits neatly into that vision.
Okay, so that's China. Big, state-led, integrated engine. Now let's pivot.
To the U.S.
To the United States, which the sources highlight as taking a distinctly different path.
Very different model.
Primarily driven by the private sector.
That's the main thrust, according to these sources.
So the core strength for the U.S. here is this vibrant landscape of private fusion companies.
Yeah, companies you might have heard of, like Commonwealth Fusion Systems, Helion Energy.
And they've attracted serious money, right?
Billions. Billions in private capital, yes. And they're pursuing lots of different technical approaches, too, not just tokamaks.
So more diversity in the bets being placed.
Exactly, which is a fundamental difference from China's more centralized government push.
The sources also noted some regulatory movement in the U.S. recently.
Yes, that was significant, the NRC.
The Nuclear Regulatory Commission.
Right. They voted to regulate fusion separately from fission.
Fission being current nuclear power plants. Why is that separation important?
Well, fusion is fundamentally different, safety-wise. It doesn't produce that long-lived radioactive waste like fission does. And the accident scenarios are very different. So having its own regulatory framework, theoretically, should streamline things.
Make it easier to get commercial plants approved down the road.
That's the goal, yeah. Acknowledging it's a different beast.
And there are some government links too, right? Not purely private.
Oh, sure. Public-private partnerships exist. The sources mention the AOE's Infuse program.
Department of Energy?
Yep. And Infuse helps connect these private companies with the expertise and, the fancy equipment at the national labs.
So facilitating collaboration.
Exactly. Leveraging those government resources.
Okay, so U.S. private sector dynamism, diverse approaches, regulatory steps, some partnerships, China. Massive state funding, centralized strategy, infrastructure focus.
It really sets up this fascinating comparison, and it raises a really important question, one the sources seem to be grappling with.
Which way works better?
Essentially, yeah.
Yeah.
Which approach China's huge state-funded build-out or the U.S.'s dynamic venture capital-fueled private innovation, which one ultimately gets us to commercially viable fusion faster?
Or more effectively, maybe.
Right. Faster, more effective. Both models clearly have potential upsides.
So bringing these different perspectives together, the sources seem to suggest, look, both nations have clear strengths.
Definitely not one-sided.
China gets the benefit of that massive government funding, the ability to just build infrastructure quickly, mobilize resources.
Rematched scale, really.
Whereas the U.S. benefits from that dynamism. Multiple shots on goal from the private sector.
Attracting huge private investment, iterating quickly.
Yeah. Different strengths, different weaknesses.
And connecting that to the bigger picture again, the sources seem to imply that the ultimate winner here.
It's not just about the science.
Not just the single breakthrough, no. It's the nation that best integrates everything.
Research, private innovation, government support.
Supportive policy, and crucially, successful commercialization strategies. How do you actually get it onto the grid?
The whole ecosystem.
Exactly. From the lab bench all the way to a working power plant feeding the grid.
Okay, so given that landscape, the strengths, the weaknesses, The sources you sent actually go a step further.
You don't just describe, they prescribe.
Right. They lay out a pretty detailed roadmap for what the U.S. could do specifically to position itself to win this race. And here's where it gets really interesting, I thought, because it's not just spend more on science.
No, it's much broader.
It's this comprehensive strategy hitting multiple parts of the problem. They say the U.S. needs to tackle, what, 5 key areas?
5 key domains, yeah. It's quite a plan.
Okay, let's walk through them. First, massively scale federal investment.
The money gap.
Yeah, we mentioned it. U.S. federal funding, around $700 million a year currently. China's estimated at $1.5 billion. Big difference.
Significant gap.
So the suggestion here is bump up the DOE fusion budget dramatically, like 2 to 3 times bigger over 5 years.
A major increase.
And prioritize flagship pilot plans, maybe using things like that milestone-based funding approach.
Where companies get paid for hitting technical goals, yeah. Incentivizes progress.
And maybe establish a National Fusion Innovation Fund, kind of like DARPA?
Like DARPA, yeah. Funding higher risk, potentially transformative ideas outside the mainstream.
Okay, so number 1, more federal money strategically spent. Number 2,
accelerate commercial demonstration projects.
Getting those first plants built. U.S. companies are aiming for the early 2030s.
Ambitious timeline.
So to help make that happen, the sources suggest using financial tools, tax incentives, loan guarantees.
Things that lower the risk for private investors.
And government procurement. Like the government agrees to buy the fusion power.
Exactly. Similar to how the Inflation Reduction Act, the IRA, helped boost solar and hydrogen by creating demand certainty.
Okay. And also fast-tracking grid connections, setting up fusion power purchase agreements, or PPAs.
PPAs are crucial. Long-term contracts to buy the power give investors confidence.
Right. So number 2 is basically creating the market conditions. Number 3,
overhaul regulation and permitting.
the red tape problem.
Yeah. We mentioned the NRC framework is a good step, but the process can still be incredibly slow.
Bureaucracy.
Right. So the proposed action is creating something like a fusion fast track.
Modeled on the FAA for space launches.
That's the analogy they use. Yeah. How the FAA streamlined things for commercial space, standardized site licensing, environmental reviews, get agencies talking to each other.
Cut down the delays. Okay, makes sense. Number 4.
Win the talent war.
This seemed like a big one. A major vulnerability.
Huge. The sources point out China graduates, 10 times more STEM PhDs every year?
10 times, wow.
And U.S. fusion startups. They're already struggling to hire the specialized engineers and scientists they need.
So what's the fix?
Well, suggestions include a dedicated national fusion talent initiative. Basically, scale up grad programs in fusion science, plasma physics, materials.
Train more people domestically.
And bring in talent from abroad. Immigration incentives, maybe like the CHIPS Act did for semiconductor workers.
Get the best minds wherever they are.
Right. And partnering more with universities. Creating applied fusion engineering hubs, maybe like NASA does with universities for space missions.
Practical, hands-on training. Got it. Okay, 5th and final point.
Lead in global standards and alliances.
Looking beyond U.S. borders.
Exactly. The U.S. is part of ITER, that big international project in France.
Right.
But the sources argue it needs to be more proactive in shaping the commercial standards for the future.
Like how reactors will operate, fuel standards, grid interfaces.
All of that. The idea proposed is forming, get this, a fusion energy NATO.
Seriously. Like the military alliance.
That's the analogy, an alliance with key allies, EU, UK, Japan, Canada, Australia.
To coordinate efforts, set technical standards together.
Yeah, establish interoperability so technologies can work together.
Yep.
And coordinate with the IAEA.
International Atomic Energy Agency.
Right, on safety, security, peaceful use guidelines. Basically shape the global rules of the road for fusion.
Wow. Okay, that's a comprehensive plan. Funding, market, regulation, talent, global standards.
It really is. And what makes it fascinating as a proposed strategy is how comprehensive it is.
Right. It's not just one thing.
No, it's not just more R&D money.
Yeah.
As the sources detail it, it tackles those critical real-world hurdles.
How to actually build an industry.
Exactly. How do you create the market, cut the red tape, get the workforce, position yourself globally?
And the sources frame this as a way to leverage U.S. strengths.
Like private innovation.
While directly addressing the areas where China seems to have an advantage with its state-driven model.
Precisely. It's presented as a strategic counter designed to compete effectively.
So what if? What if the U.S. actually did all this? Executed this plan successfully?
Well, the sources paint a pretty compelling picture of the potential outcome.
What's the timeline they suggest?
They suggest the U.S. could potentially become the first nation to deploy commercially viable fusion power plants, maybe as early as the beginning of the 2030s.
The early 2030s.
It's an aggressive goal, but that's what the potential payoff could be timing-wise.
And getting there first would position them to, what, dominate that future market?
That massive global fusion industry, yeah, projected to be worth over $1 trillion by 2050. Being first mover could mean capturing a huge share.
And geopolitically.
It could be a major statement, a way to, as the sources suggest, reassert technological and clean energy leadership, particularly relative to China.
Wow, okay.
It really just drives home the sheer magnitude of the opportunity that these sources are describing.
It's not just science.
No, it's building a future energy economy and all the global influence that could come with that.
So this deep dive, I mean, it's really underscored just how intense this global race for fusion energy is and how many layers there are.
Absolutely. Science, engineering, policy, economics, geopolitics,
Yeah.
it's all in there.
It's this really compelling story, a competition between these different national approaches, right?
China's centralized state model versus the U.S.'s more decentralized, private sector-driven innovation.
All chasing this prize that has just most unimaginable implications for energy, for economies, for the global balance of power.
Truly transformative potential.
So looking at these strategies laid out in the sources, especially that detailed U.S. plan,
Yeah.
it really makes you wonder, doesn't
That
it?
sees you thinking.
Does the sheer scale, that centralized power of state investment, like China's, does that ultimately give you a faster path, especially for building out big infrastructure for a new energy source?
The ability to just mobilize and build.
Or is it the dynamism, the diverse shots on goal, the access to private capital in that private sector-led model?
Yeah.
Is that the real key to unlocking commercial fusion power first?
State control versus market innovation. Which wins in the end for something this complex?
Yeah. That's definitely something worth mulling over as this whole race keeps unfolding. It's going to be fascinating to watch. Well, thank you again for sending these sources. They gave us such a clear window into this critical global competition.
Glad they were useful. It's a vital topic.
For sure. We'll see you on the next deep dive.